So this particular example ends up needing to repeat one of the numbers, right? 4 and a 4. Don't forget those possibilities. In fact, most algebra textbooks, and I don't know whether this helps or not, this is up to you, most textbooks, ours included, will include factorizations like this as something separate. So there's actually a separate topic in ALEX for factoring something where this expression is repeated, x plus 4, x plus 4. Because what's another way of writing x plus 4 times x plus 4? X plus 4 squared, exactly. So in those situations, we call this trinomial a perfect square trinomial. And it's not as though you really need to know up front that a trinomial is a perfect square in order to be able to factor it, but this is one example of one that is. So the sum and product method that we use here will always catch that, right, as long as you remember to include using the same number twice as one of your possibilities in the list. Okay. X squared plus 8x plus 16 does factor as x plus 4 times x plus 4, or another way to rewrite that is x plus 4 squared. This example also provides us with some confirmation of something that people were still screwing up as of the last exam, which is the opposite problem. The opposite problem is I give you on an exam x plus 4, the quantity squared, and I ask you to simplify it to carry out the product. And what a lot of people do is what?
Square the 4.
Square the 4, square the x, and try to just write x squared plus 16. But I think this example illustrates why that doesn't work. Because x plus 4, the quantity squared, is what you get when you factor the expression up here at the top, x squared plus 8x plus 16. So there is no way to square a binomial or a polynomial expression without writing it out as a multiplication problem and using FOIL. Okay. So always FOIL when multiplying or squaring any binomial expression. Okay. And something which FOILs itself out to x squared plus 8x plus 16 can be factored as x plus 4, the quantity squared. All right, so back to basics. X squared minus 3x minus 4. Who's got that one? Okay.
X minus 4, x plus 1.
Minus 4 plus 1. One of the things you might find as you go forward is that managing negative signs is probably one of the mental pretzels you need to twist yourself into. So let me ask you this. We needed two numbers here whose product was equal to negative 4. What does that tell you about the two numbers?
One has to be negative.
That's right. So anytime the product that you seek is negative, as it was in this example, that means that our two numbers have to have opposite signs. One has to be negative, the other has to be positive. So that could be a helpful mental trick for you going forward. Look at that constant at the end first. And if that constant is negative, you know that the numbers you're looking for will have opposite signs. If the constant is positive, you know the numbers at the end will have to have the same sign. Right. So when you look at the next example, x squared minus 4x plus 4, what were the numbers that you needed in that example? Both negative. Negative 2 and negative 2. So those numbers, again, had the same sign because their product needs to be positive. By the way, this too is an example of a perfect square trinomial because we've repeated x minus 2, x minus 2. So we could, if we wanted to, carry it forward into x minus 2, the quantity squared. How about the next one's a little bit subtle, x squared plus x minus 2? Yeah.
X minus 1, x plus 2.
Minus 1 plus 2, yeah. Don't forget, when the x is bare by itself, put in a little coefficient of 1. Sometimes these problems get weirdly more difficult when you're asking about smaller numbers. I need two numbers which multiply together to give me negative 2 and which add together to give me positive 1. Well, positive 2 and negative 1 fit that bill. X squared minus x minus 42? Yeah.
6 and negative 7.
6 and negative 7. So x plus 6, x minus 7. Great. X squared plus 13, x plus 42? Similar question. What did you have for that one? How about plus 6 plus 7? Positive 6 and positive 7 multiply to 42. They also add together to 13. How about x squared minus 6x minus 7? Positive 1, negative 7. Great. Their product is negative 7. Their sum is negative 6. X squared plus 2x minus 8.
X plus 4 times x minus 2.
Plus 4 minus 2. Awesome. X squared plus x minus 20.
X plus 5, x minus 4.
Plus 5 minus 4. You get the sense that this skill that you're working on right now, these muscles that you're currently building, these are your expertise muscles in the area of factoring. This is going to be a technique you use over and over again when you factor, when you solve equations that involve factoring, as we're about to see. So the more practice that you get with this, really, this is a skill that will really go a long way towards setting you up for success in these two modules. All right, so the last two examples are a little different. How did you approach them? 5x squared plus 10x minus 15. What'd you do? Dylan? Greatest common factor. Yeah, exactly. So the first thing you did was identify a greatest common factor among these three terms. And what was it? 5. And once you bring out that greatest common factor, what do you have left inside?
1.
So you got 1x squared. How many x's? If we factor a 5 out of this trinomial, 2x, and the constant? Negative 3. And so what needs to be factored is now x squared plus 2x minus 3, and that 5 will just come along for the ride now. That greatest common factor still needs to be a part of your final answer, but we don't have to do anything more with it, right? It's just going to stay where it is. So how do we factor x squared plus 2x minus 3?
Negative 3, positive 1.
Negative 3, positive 1? Yeah, check that. Remember, the sum needs to be 2. And since the sum needs to be positive, that means the larger of the two numbers in absolute value needs to be positive. So we want the plus sign on the 3 so that the sum can remain positive 2. So 5 times quantity x plus 3 times x minus 1. What changes when we do that same approach with our last problem? Greatest common factor is still the same. But what do I have inside now? X squared plus 4x plus 3. So my 5 carries through. But what's my factorization of x squared plus 4x plus 3? Yeah, we've got pluses in both cases now. Plus 3, plus 1, and we're done. So this was a good sort of tour de force through all the various different sign combinations that we can get when trying to factor a quadratic trinomial. Right? We had examples where the constant was positive. We had examples where the constant was negative. We had examples where the b, the linear coefficient, was positive, and examples where the linear coefficient was negative. We had most of our examples where the factors were different, but we had a couple where the factors were the same. And so we ended up with a perfect square. And we finally had a couple of examples at the end where before we could use the sum and product technique, we had to bring out a greatest common factor. So this is a good illustration of, in our Module 7, all of the various factoring techniques that we might be expected to use to factor an expression.